Hello everyone, welcome back. Myself Rahul. So today I'm going to solve a problem related to recursion. Problem name is letter combinations of a phone number. So let's go through the problem. In this we are given a string containing digits 2 to 9 inclusive. We have to return all possible letter combinations that the number could represent. Return the answer in any order. The mapping of the digits to letters, just like on the telephone buttons, is given below. Note that one does not map to any letters. So just as the telephones used to be like we have these given to us. So the character 2 denotes ABC, 3 denotes DEF, so on and so forth till 9. 9 denotes WXYZ. So ultimately like we would be given a digits array, which is example 23 over here. So for 2 what are the possible values ABC, and for 3 what are the possible values DEF. So we have to form all possible combinations that can be formed using this digits array. So let me try to explain that using an example, and it is given that we can return the answer in any order, so it doesn't matter whatever the order can be. So taking this example only, let's see what are the possible ways in which we can have the final vector of strings that needs to be returned. So we have a digits array that is given to us 23. So it is also given that each digit corresponds to a set of characters, which are nothing but the telephone numbers itself. So in the telephone, 2 corresponds to ABC and 3 corresponds to DEF. Right. So what we have to do is we have to take one character from each of these strings. So if we suppose take one character A from this and one character from this, so the resulting string would be AD. The other possibility can be we take A from here and E from here, so it can be AE. We take A from here and F from here, so it can be AF. Right. Similarly, we take B from here and D from here, so BD. Similarly, BE, BF. Suppose we take C from the first set and D from the second set, so it is CD, CE, and CF. Right. So as you can see, we are just considering a single element from each of the strings. Like for 2 the string is ABC, for 3 the string is DEF, right? So we have to take only one character from those strings. So it is a very classic example of recursion. So how the recursion tree is going to look like in this scenario would be like initially we would be having 3 possibilities with us. So we are given a string called suppose 23. So we have 3 choices with us available, whether we can consider A, we can start the string with B, or C, as we have seen over here. Right, we can start the string from A, B, or C. So suppose we have considered A, so here as well we have 3 possibilities with us. If a string is starting from A, we can consider the second character as D or E or F. Similarly, if we have the first character as B, same here we have the 3 possibilities with us, D, E, and F. Same is the case if we consider C. Right, so as we can see, like what are the possible answers generated in this case. So once we have reached the leaf node, which means we don't have any further character of the digits string to be processed, which means we have reached the end of the recursion tree basically, right? So what are the possible strings formed? So the string is AD in this case. Similarly, AE is also one of the cases, and AF would also be one of the cases, right? Yeah. Similarly, AF is also one of the strings. Similarly, if the string is starting from me, so this is also one of the possibilities, BD. Similarly, BE, BF. Right. So as we can see, like we are traversing over the recursion tree until we are reaching the leaf node. That possibly will be one of the possible solutions. Right, I will try to code this problem. It's a very simple problem. So finally we have to return the vector of strings, and the vector of strings by mean like this is a string, this is one string, this is one string, so it's an array of string or vector of string. Right, so whatever I have to return, I will create this vector of string over here. Let's call it answer. And also I need to somehow maintain, like we are given the digits string, right? So each character of the digit string would be a character in itself. each index of the digits string, right? So I have to create one map basically. So let me create one map. It can be map of character and it will be string, right? So let's call it mp, and in this map I'm going to insert, so what I can do is mp of character a will correspond to a string called abc. So this is I'm doing so that when I am traversing over the digit string, if I am at a particular index, that particular index will give me the character at that particular string, and corresponding to that particular character, I can get what are the possible values I can have for that particular character. So for 2, I will be having ABC. It's not A, it says 2. Similarly, MP of 3 would be nothing but DEF. So similarly, for 4, GHI. And this is the tedious job that we have to do in this problem. And when MP of 7 would be PQRS, and MP of 8 would be TUV, and MP of 9 can be WXYZ. Right, so we have created this map. So if I want to know what is the possible character values for a particular digit, I can directly look up to this map. Right, so I will create one string so that I can update this string whenever I am doing this recursion call, and whenever I have reached to the end of my recursion tree, I can populate whatever the value is in my string str into my answer vector. Right, here I am going to call one helper function, and in this helper function I am going to pass this string and the current index which I am currently at in the digits array. So I'm going to start, like suppose the digits array is 2 3 4. So I have, this is index 0, this is index 1, this is index 2, right? So I will be passing a starting position from I am going to start, so it is index 0, it is str, and I can pass the digits array, digit string as well. Right, so let us write the helper function. So it is not going to return anything, we are just going to update the answer variable or the answer vector inside this helper function. So here I'm going to pass this string, the index I am at currently. So initially it will be 0, which means I am starting from the beginning of the string as in the digits array, and I can pass this digits array as it is. I can pass it by reference so that I don't have to copy this digits array when I'm calling this helper function. It will save me on the space aspect as well as on the time aspect as well. Right, so yeah, here I can mark an termination condition if my index value is greater than equal to whatever the size of my digits array is. Yeah, so size of my digits array as in, like, I have reached to this particular part of the tree, and here and the size of the digits array was nothing but 2, right? So when I reach this position, this part of the recursion tree, my index would have become 3, which is indicating me that I don't have to process further, and whatever the value is present in my string, which would be AD in this case, I just insert that into my answer vector. So answer dot push back my string. whatever the value is in there, the str variable, and I can return from there. So this is the termination condition. We could have written it in the end, but anyways it's fine. And now I'm going to create one temporary string which is going to hold what are the possible values for a particular digit. So I am at a particular index in this digits string. It is nothing but an array actually. So I can iterate over this map, not iterate, I can find what is the possible string value for this particular index. So mp of digits of index. Yeah, sorry. Yeah. So this is going to give me, so initially it will be, suppose 234 was the string, right? So this step is going to give me ABC as the output, because first index value is 0 when I'm going to call this function for the first time. So it will give me ABC by looking into inside this map. So now what I have to do is I have to iterate over all the possible values in this string. So I can just write a for loop over here. For int I equal to 0, I less than temp dot size I plus plus, and my string of index. So now I'm going to update my string str. It can be nothing but temp of I. Yep. So in this str I will in the first iteration I'm going to just insert a. So str of index would be a at this point, and in the second iteration instead of a it will be b. In the third iteration instead of b it will be c. So basically I'm creating these three parts of the tree, a, b and c. And once I have inserted this, I'm going to recursively call for the further subparts of the tree, for the uh, part of the digits array. So in this I'm going to call pass this string as it is, and index value would be updated as 1. So initially I have covered all the possible values that can be found using this tool. Now I need to go to this 3, right? So this 3 is nothing but index plus 1 location in the digits array. So I have updated as index plus 1 and recursively calling as digits. I think yeah, this should be it. So when my helper function is finally returning, I can return answer over here. Let me try running this. Okay. Yeah, I think the solution is yeah, I got the issue. So the issue is like whatever the size of my digits array is, right? So if the digits array is supposed to is 234, right? So correspondingly, whatever the strings that are going to be formed, those are also would be of length 3, because corresponding to 2 there will be one character, corresponding to 3 there will be another character. Same is the case with 4. So what I need to do over here is I need to initialize this string with digits.size. So digits.size in this example is 3, and I'm going to initialize this string with nothing but spaces. Compile error. Let's see what is the issue. Yeah, I think the issue over here is yeah, it is not a string. I can initialize it with character. Let's see. Yeah, this looks fine. I will submit this. Also, okay, I need to handle one more scenario, this edge cases. So what I can do over here is if the size of the digits array or the size of the digits string is 0 itself, right? So I can return from here itself, return answer. Submit it now. Yeah, yeah. So I have run this solution again. So the runtime and memory usage are looking fine. So this was a very simple problem, I would say, regarding recursion. So we have used the iterative solution as well. Like we are iterating over whatever the possible values there can be for a particular digit, so that we can recursively call for those sub values. And yeah, I hope the solution is clear. So if you have any questions or any improvements to this is so please do comment, and I will see you next time with another problem. Thank you guys.